Greetings and good day to all of you. Today, the topic of this presentation is Values and Data Types, Chapter 4. And the contents of Chapter 4, which we will understand through this presentation, are data types, variables and constants, operators, and type conversion. Now here comes the introduction of data type. The definition says that it helps to identify the data and dictates the method of handling it. See, when we are accepting the data from the user, it could be of integer data, or it could be of alphabetical data, or it can be of fractional data. So data type allows us that what sort of data we are accepting from the user, as well as which method will be used for handling the different types of data. If it is of integer data type, it will be handled by the different method. If it is of alphabetical data, it will be handled by another different method. Now there are two types of data types in Java. These are primitive or fundamental data type, non-primitive or reference data type. Now primitive data types are those data types which are inbuilt in Java language. They are not created by the user. And the categories of primitive data types are integer, fractional, character, and the boolean. And non-primitive data types are derived or they are built with the help of primitive data types. And the categories of non-primitive data types are class, array, and string. Now in this slide we will be introduced with the categories of primitive data types. The first category is integer primitive types. The definition says that it is used to represent a number without a point. So all non-decimal numbers are represented with the help of integer primitive types. And the data types which are used for handling this sort of data are byte, short, int, long data type. So all these four data types, byte, short, int, long, are used to represent a number without a point. The another is fractional primitive types. It is used to represent a number with points. So all decimal numbers are represented with the help of fractional primitive types, and the data types which are used to represent this sort of data are float and double data types. The next is character primitive types. It is used to represent a character, a single character in Java, and the data type which is responsible for this is char data type. The next is Boolean primitive types. It is used to represent the two states that a condition can have, either true or false. So any condition can have only two results, either the condition is true or the condition is false. So this sort of data is represented by the Boolean primitive types. Now in this slide, you can see the data types, their size, their range, as well as the description. Now, what do you understand by the size? Size means that how many bytes or bits a variable of a certain data type can occupy in memory. Again, I am repeating that how many bytes or bits a variable of that data type can occupy in a memory. Whereas a range means the initial and the final value or the limitation of a variable of a certain data type can take place. Now, the first is byte. The size is only 8 bits or a 1 byte, and their range is -128 to 127. -128 to plus positive 127. It can hold these sort of characters, and the description is that it is used for bitwise operations. Bitwise operations means it is used to operate on binary numbers, or we can say on the bit patterns. The next is char data type. The size is only 2 bytes and it is used to represent a character. The next is short. The size is only 2 bytes. The next is int. The size is 4 bytes. The next is long and the size is 8 bytes. It means 64 bits. The next is float. The size is only 4 bytes or 32 bits. And another one is double. The size is 8 bytes or 64 bits. See, float and double are used to handle the decimal sort of data. And what is the difference? The size of float is only 32 bits, whereas the double holds 64 bits. Whereas the float data type, after a decimal, it can represent the values up to 6 significant digits. Whereas in case of double, after the decimal, it can represent the values up to 15 digits. Now, in this slide, we will understand the difference between variable and constant. Variable, the definition says that it is a name given to memory location for storage of data. So, what is a variable? It is a name given to the memory location where data is stored or need to be stored. And the important point to know is that how we declare a variable. The syntax is first we write data type, the space, and the name of the variable. So, in my example, int n1 comma n2. What is this int? This is a data type. So first you write a data type, then space and the name of the variable. Now n1 and n2 are both of int data type. The next example is double salary. Double is data type, there's space, salary is the name of the variable. So what is the syntax of declaring a variable? Data type, space, name of the variable. Constant, these are the values that are assigned to the variable. So simply constants are values which we are assigned to our variable. So for example, I have declared n1 and n2 data type of int data type. So what values I am assigning? 67, n1 equal to 67. So what is the 67? This is a value which I am assigning to my n1 variable. 90 is a value which I am assigning to my n2 variable. Now in this slide, we will understand the variable initialization. A variable may be initialized by assigning specific value to it. So when I'm writing n1 equal to 60, I'm assigning 60 value to my n1 variable. It means I'm initializing my n1 variable. Now there are two types of initialization, the static initialization and another one is dynamic initialization. And what is the difference between them? The first point says that in the static initialization, the variable is initialized during its declaration. So when you declare a variable, you assign a value to it, that is known as a static initialization. And the dynamic initialization, the variable is initialized at the runtime. So how the variable is initialized? At the time of execution. The second point says this process uses direct assignment of a variable with defined constant. So for example, I am writing n1 equal to 10. So I am giving direct 10 value to my n1 variable. It means this is a case of static initialization. In another example, string name equal to SHS. So you are assigning this SHS value to my name variable, that is static initialization. Whereas the second point of dynamic initialization says that in this process, a variable is assigned with the outcome of any arithmetical or logical function. So for example, I have declared a variable double res. Now res is of double data type. At the time of execution, this statement will execute it. What statement? Math.square root 9. So what is the answer of this arithmetical function? That answer will be stored in my res variable at the time of execution. So that is a case of dynamic initialization. Or I'll give you one more example. See, if I'm writing a equal to 10, fine, I'm writing b equal to 20, both a and b are of int data type, and I'm writing c is equal to a plus b. Now this is a case of dynamic initialization. A is of int data type, b is of int data type, both I am assigning with 10 and 20 value, and this c is of int data type. At the type of execution, answer of a plus b, it means 30. So this c will be assigned with a 30 value at the time of execution. So that is a case of dynamic initialization. Now in my next slide, we will understand the concept of variable scope. The variable scope, the definition says that it means the range of accessibility up to where a variable can be accessed. So the variable scope defines the range of accessibility. If a variable declared in a particular block, then it can be accessed anywhere within that particular block only. How will you define a particular block? We will define a block with this example. This and this. This is a particular block. Any statements within a curly braces makes that particular block. So for example, I am declaring a equal to 10. This is of data type, and outside of that block, if I am writing system.out.println a, that is a wrong statement. It will give you a compile error that you cannot find this variable a. Now in this example, see, I have declared a class test in the main function I'm writing a equal to 5, b equal to 10, and then inside a if block I'm declaring s equal to a plus b, where I'm declaring s inside this curly braces. Fine. Now for the s, this is a particular block, and after that I'm writing outside the block, I'm writing system.out.println s. Now this program, when I'll compile, it will give me the compile error that cannot find the s variable. Why it cannot find the s variable? Because the s variable is declared inside this particular block of if. If I have written this line system.out.println s inside the if block, it will not give an error. But if I write this line outside of the if block, it will give me an error that it cannot find the s variable. So that makes the variable scope. Variable scope means the range of accessibility. You can access the variable where it is declared in a particular block. Outside that block, if you are trying to access, it will give you a compilation error. Now, here comes the symbolic constant. The definition says that it is a named constant that is used to represent a fixed value that never changes throughout the program. So, if you want a value which should not be changed accidentally or by any mistake, that is an example of symbolic constant. And how we implement the symbolic constant in Java through the keyword final. See, what is the syntax of declaring this? We write final and then space, data type, space, and any symbolic name is equal to value. So for example, I have declared a variable pi. What is this pi? In my case, it is a name, or you can say symbolic name. How I'm declaring? Final, and the data type is of double and name is pi is equal to, what is the value? 3.142. Fine. So this value cannot be changed throughout my Java program, and if they try to change this value, it will flash you an error. What is the advantages? The advantages is this, that it should be proper secure. No one can accidentally make any changes in this value. In the next slide, we will understand the definition of expression. Expression is, it is a collection of different values and operators any plus, minus, multiply, fine, that results a value. Two kinds of expressions in Java are pure expression and mixed expression. The pure expression is an expression that are formed using the variables of same data type. So for example, I have C equal to A plus B. Now A is of int data type, B is of int data type, again C is of int data type. So when all the variables belong to same data type, this is a pure expression. Whereas in mixed expression, these are the expressions that are formed using the values of different data type. For example, I have byte A equal to 5. Now A is of which data type? Byte. Then short B equal to 10. B is of which data type? Short. And then C equal to A plus B. Now C is of which data type? Int. So when all the variables belong to different data type, this sort of expression is known as a mixed expression. Now, in this slide, we will introduce with the concept of type conversion. The definition says that it is the process of converting one data type value into another data type in an expression. Now, which expression? Mixed expression. Why? Because in a mixed expression, we use the variables of different data types. So, when one data type value is converted into another data type, this process is known as type conversion. There are two types of type conversion: implicit type conversion and explicit type conversion. Now, implicit type conversion take place automatically, whereas explicit type conversion take place by the user intervention, or user has to type the syntax. Now, implicit type conversion take place when a data type of lower size is assigned to a data type of higher size, whereas explicit type conversion take place when the data type of higher size is assigned to a data type of the lower size. So the definition says that an implicit type conversion take place automatically by the Java compiler from the lower size data type is assigned to a higher size data type, whereas explicit type conversion take place forcefully with the help of user from higher size data type to lore size data type. Now in implicit type conversion, when we are assigning a lore size data type to higher size data type, there is no loss of data. Whereas in explicit, when the higher range of data type is assigned to lower range of data type, there is possibility of the loss of data. Now see the example of implicit. We have a variable which is of byte. Fine. The size of byte is only 1 byte, 8 bits. Whereas in B, the data type is short. Fine. The size of the short is 2 bytes. Now we are doing int c equal to a plus b. Now c is of which data type? Int. So easily a plus b result can be assigned to the c variable because c has a higher size. C is the variable of int data type which is of 4 bytes. Now in case of explicit type conversion, we have taken a which is of short data type and we have a b which is of long data type, and we are storing the result of a plus b into a c variable which is of int data type. Now in case of long, it is of 64 bits. Fine. It has a size of 8 bytes. So now this 8 byte data cannot easily transferred into my C variable which is of only 4 bytes. So what I need to do? I need to typecast typecast this expression. And what is the syntax for typecast? The syntax is this int. I have to type the expression in which I want to transfer. So I want to convert this b variable which is of long into int variable. So I type int over here and then result will be assigned to my c variable. Now this is the hierarchy sequence of data types for type conversion. When we move from left to right, byte, after this short, int, long, float, double. Double has the highest size. What is the size of double data type? It is used to store 64 bits of data. So when we move from left to right, this is a case of implicit type conversion. Easily the lot size of data type can be assigned to higher size of data type. But when we move from right to left, this is a case of explicit type conversion where we are assigning the higher data type values into a low data type values. So in explicit type conversion, we have to type the syntax.
Now I show you the working of the typecasting. See, in this program, what I am doing in the class A1 in the main function, I have declared a variable A of byte data type and initialize it with value 10. And in the another line, I have declared a variable B of int data type and then B equal to A. What I am doing in this line, I am transferring the value of A to B. Now A is of byte data type, which is only of 1 byte. So I am transferring the data of 1 byte to higher data type which is of 4 byte. So if I compile this program, there is no error. Now this is a case of implicit type conversion where the low data type is converted into a higher data type. Fine. Now again I made a change here and instead of byte I write here int, and instead of this int I made a change here and convert those into a byte. Now see what error will come here. I compile this program. It shows me an error. What error it is? The error is incompatible types. So that is a case of explicit type conversion. Now what I need to do? I need to write the typecasting here. Byte. I write here, it means now A which is of int data type, the value is converted to byte and will be stored in my B variable. This is a case of explicit type conversion which require a user intervention.
Now this slide introduces us with the concept of type promotion, and the definition says that in a mixed expression, the resultant data type is always converted to the data type of the largest operand. This is called type promotion. So for example, we have three variables. One is of float, another one is of double data type, the another one is of int data type. If we add all these variables, the answer will always be in a double data type. Why? Because double has the higher size. The next is char plus char. Answer will be in int. Char plus int. The answer will be in int data type. String plus int. The answer will be of string data type. String plus char. The answer will be of string data type. So for example, predict the output. Now in this, A plus 4. What is this A? This A is of character data type and the 4 is of integer. So character plus integer, the answer will be in int data type. So what is the style value of A? It is 97. 97 plus 4, the answer is 101. After this, SHS plus 12. The SHS is of string data type, 12 is of integer. So string plus integer, the answer will be of string data type. So what is the answer? SHS 12. This is 101. A plus B. Now A is of char data type, B is of char data type. If we add two char data type, the answer will be of integer. Now what is the star value of A? 65. What is the star value of B? 66. So the answer will be 131. The another one is Muga plus 4. The Muga is of string data type. The 4 is of character data type. String plus character. The answer will be in string. So the answer is Muga 4. The next is integer plus character. Now, int plus character, the answer will be of int data type. So 3 plus 9. 9 is of character data type. So what is the star value of 9? 57. So 3 plus 57, the answer will be 60. Now, after this, we come to the next slide. It says that give the reasons and why the following initializations are incorrect. See, int a equal to 5, short b equal to a. Why this initialization is wrong? Because in this initialization, we are assigning the value of a to the b. Now, a is of int data type and b is of short data type. Int has a higher size than the short, so that is why this conversion, this initialization is a wrong. This is a case of explicit type conversion. We have to type the syntax. What the syntax we have to type? Short b equal to a. Instead of this line, we have to write short b equal to, before a we have to write short and then bracket, and here I am writing a. This is the correct syntax. The second is double a equal to 5.3, float b equal to a. Again, this is wrong. Why? Because double data type is used to store 64 bits, whereas a float is used to store 32 bits. We cannot assign 64 bits to the 32 bits. So again, this is a case of explicit type conversion. And for explicit type conversion, we have to type the correct syntax. So what is the correct syntax? Float b equal to, so before a, you have to write float and then a. Now after this, the C is int a equal to 0, 1, 2, 3, 8. Again, this is wrong. Why this initialization is wrong? Because this value is too large for integer data type. So this is incorrect. The D part is float a equal to 17.36f into b equal to a. Again, this is wrong. Why this is wrong? Because a is of float data type and we are assigning a value into the b variable which is of int data type. So this is a case of explicit type conversion. What we have to write before a int? Before a, we have to write int and then a. The E part is boolean a equal to true, int b equal to a. Again, this initialization is wrong because boolean data type cannot be converted to integer data type. So this initialization is wrong. Now with this is the end of the tutorial. So with many thanks, stay home, stay safe.